Hi, I'm Benny D, and in this video we're going to look at integration of circular functions. Hey, so we've got just a few rules to have a look at and then apply those rules. So our first rule is the integral of sine of kx plus a dx is equal to -1 on k cos of kx plus a plus c. Okay, so you can see this is where it gets a little annoying because our negatives are opposite to when we differentiate. So when we differentiate, sine goes to positive cos, but when we anti-differentiate or integrate, okay, we go from sine to negative cos. So that's a little thing that we're going to make sure we remember. And then similarly, the antiderivative or integral of cos of k of x plus a dx is equal to 1 on k sine of kx plus a plus c. Okay, don't forget our plus c's when we don't have our terminals on our integral sign. Okay, lastly, in blue here, I've got the antiderivative or integral of tan of kx plus a dx. Now I did it in blue because this sits actually outside the course, but for completion, I wanted to show you what the integral of tan was, because otherwise you'd be thinking, well, why can't we do it? Okay, and the reason is our answer is -1 on a. So that should be on k, not on a, on k, log to the base e of the modulus of cos of kx plus a plus c. Now the modulus is just these straight lines, and what it basically means is anything in here has to remain positive all the time. Okay, so as I said, this sits outside the scope of the course for Year 12 methods, but I put in there for completeness. So let's have a look at a couple of worked examples. So our first one here is the integral of sine of 3x plus pi on 4 dx. Okay, so we're going to use this rule up here. So we're going to get -1 on k, that's our coefficient of x, that's 3. Okay, cos of our 3x plus pi on 4 plus c. So it's pretty straightforward. Not a lot's actually changing here. Okay, we're changing our trig function from sine to cos, okay, and we're putting this term out the front, but otherwise everything pretty much stays the same. Okay, so we'll have a look at another one. Okay, so I've got two more that I want to look at today. Okay, so for this one, we're integrating from 0 to pi on 4 of sine of 2x dx. So this time you can see we do have terminals on there, so we won't need the c. So from here we're going to get our square brackets, and we're going to get our -1 on 2. Okay, sine goes to negative cos. Okay, so then cos of 2x. Close our brackets, and we're going from our 0 to pi on 4 for this one. Okay, so we need to sub our values in now. So we're going to get -1/2 cos. Now 2 times pi on 4 is going to be pi on 2. Okay, minus -1/2 cos of 0. Okay, so we're going to get cos of pi on 2 is 0. Okay, we've got take a negative, means it's adding, and cos of 0 is 1, so 1 times 1/2, so adding on 1/2 there, which gives us overall an answer of 1/2. Okay, our last one here, okay, is integrating sine of theta minus pi on 4 d theta from pi on 4 to 9 pi on 4. So we need to be a little bit careful here, okay, because if we did this without thinking too much about it, our answer would be 0. Okay, but it's actually not 0. We need to be careful, because if we actually graph this, we'll see it's going to look something like this, where we start at 0. Sorry, not 0, at pi on 4 instead of 0, sorry, because of that translation. And we come up here, funnily enough, to our 9 pi on 4. Okay, so because of this, we've got this signed area in here. Okay, so this area, I've not drawn it the best, but this area, these two areas will be equal in size, but this one will be negative, so they actually completely cancel each other out. So what we need to do is we need to be a little bit careful and realise that this needs to be split and made between pi on 4 and 5 pi on 4, and 5 pi on 4 and 9 pi on 4. Now, we could be looking at finding the area of both these things, making this one like taking the area away to make it positive, okay, and then bringing it all together. But these two areas are the same size, so we don't actually have to. So what I'm getting at is we could go from pi on 4 to 5 pi on 4, okay, of our function, and then take away that area from 5 pi on 4 to 9 pi on 4 of our function. Okay, and we take it away because this would be a negative area, so then taking away a negative is going to add it on. Okay, and we could do all that work, but we really don't need to, okay, because these two areas are the same. So instead of doing that, okay, what we're going to do is we'll do 2 times the area from pi on 4 to 5 pi on 4. Okay, of our function sine of theta minus pi on 4 d theta. Okay, because there's no point doing all this work twice over. Okay, so if we're going to do that, we're going to get 2 times. Okay, we're going to get negative cos. Sine goes to negative cos. Now, our coefficient of theta instead of x this time is just 1, so nothing's going to change there. Of theta minus pi on 4 from pi on 4 up to 5 pi on 4. Okay, so what we do is I'm going to come up here now. Okay, so I'm going to get 2 times. Okay, we're going to have negative cos of. Now we've got 5 pi on 4 take pi on 4 is going to leave us with just pi. Okay, I'm going to take a negative, okay, so it's going to be plus cos of 0, sorry, just squeezing that in. So when we do that, okay, we find that we're going to get 2 from here, so this should be bracketed in here. So we're going to get 2 from in here, so then we have 2 times 2, okay, which is going to equal 4. Okay, and in this case, square units, or whatever we like. We weren't given any other units, so we just go with square units. Okay, so you can see sometimes you need to be aware, okay, that we're going to be going above and below the x-axis here. Now this didn't have a coefficient or anything like that. Our amplitude is just 1. So for example, we would need to be careful. So our method here of just finding half of it and doubling it would work fine for this one. But for example, if we had a function, it could just be, say, sine of x plus a half. Okay, well now we're going to do something like this. Okay, and we would need to split things up because we'd have an area here, we'd have an area here, and we'd actually have a little area in here as well. So it's not that neat, oh, okay, this is just the same as this. Okay, so it doesn't work all the time, but you need to be aware of when it will, because it's going to save you a lot of time when you're doing these questions. So look, hopefully that'll be enough to get you through.